I am Professor Ramchandar from NITK Surathkal. I think some of you may be knowing. I am here for last 23 years at NITK. And major my research areas are rock blasting and slope stability. I'm working on these projects only, mostly industrial sponsored projects, and I carry out. So the MEAI team, Vidyarthi sir requested me to make a presentation related to blasting. I thought I will speak something on the role of electronic detonators on rock blasting. The electronic detonators we have started in industry use to a certain extent, but not on a large scale, because especially there is a lot of cost difference between other initiation systems and electronic detonators. Actually, what is the need of this electronic detonator? Why they are required to be used in the industry? What are the advantages? We'll go through in brief. So 1 minute. Hello. Yes. Yeah. Can you call me after I'm in a meeting? Call me after 1 hour, 6:30 or tomorrow. See, just I'm touching very basics. I'm not going into much details. The rock blasting is an essential activity to break the rock mass in hard excavations, especially in mines, tunnels, canals, and so many things. Wherever hard rock is there, the blasting is the cheapest technology to break. Though there are so many other alternatives have come, but those productivity is very low and the cost is very high. So when this blasting has started, as you know, the oldest explosive is gunpowder, which was there is no clear historical evidence who invented. People say Chinese invented. On the other side, even Arabians invented. But history is almost 10 to 14 centuries. Though actually it was not invented for blasting. Basically, it was used in the initial days for hunting purpose. But the blasting is used first time in the year 1627 in a Hungarian gold mine. So even if you say history of blasting in mines, we have roughly around 800 years of history. And first time in the civil engineering project, it was used in one of a tunnel in France in the year 1679. So, though there is the blasting is a very vast subject, I am sticking today's lecture mostly on electronic detonator. So, once you have an explosive, you should have a initiating device. Like when you are buying a candle, you must buy a matchsticks or a lighter or something to initiate it to get the light, right? So, similarly, when you are buying an explosive, you must buy an initiating device to safely initiate it. There are historical evidences where there are so many initiating devices starting from 1830 to even today. And there are a lot of technical advancements. Most of present generation are last 20-30 years, what we have seen is electric detonators, including instantaneous and delay detonators, detonating card, nonel based shock tube, and of late electronic detonator. Most of you, those who have in senior level, I think you must have started your career in large scale mines, started using a detonating card with a card relay. Those who are in middle management are just young generation, you may be using nonels. And you see, after few years, industry will be commonly using electronic detonator. If you see in this slide, this non-L based shock tube detonator was introduced, or Nobel has patented this in 1973. But in India, we started using only in 90s. Means to enter this technology into Indian mining industry, it took more than 20 years. Now, if you see, this electronic detonator was came into picture in the year 1986. If patents on electronic, number of patents from different countries like Germany, US, Canada, and these things. But you see, though the technology was introduced in 86, still we are not able to use these electronic detonators on a large scale, even after 38 years. because mainly the major reason is cost. In fact, when these nonels were introduced at that time, also a lot of hesitation from the industry to use it, because uh, initially the D code was costing, when I started my research as a MTech student from IIT Banaras, the D code was costing around 6 to 8 rupees, whereas nonal based shock tube is costing around 20 to 22 rupees per meter length. These things, most of you, these are detonators. This is a detonating cord with a cord relay. This is a nonal based shock tube initiation, shock tube detonator. This is a electronic detonator. And mostly this will become a soon history. Electric delay detonator, government has asked the manufacturer to stop the production. I think from next December onwards, we will not see these electric detonators in the industry. It will become a history. Though detonating cord is there available, still because of a lot of disadvantages with detonating cord, the usage has come down drastically. Most probably many are using now, even small scale quarries also started using nonal based shock tube detonator. Nonal is actually a trade name, but still in industry we call it as a nonal. But every industry, every manufacturer has come out with their own trade name, like Radiate, Excel, Hercudate, Twindate, so many names are there. Basically, it is a shock tube initiation technology. Now, some of the manufacturers have started manufacturing even electronic detonators in India. So, if you broadly classify, if you see any textbook, you must have done seen during your BTech subject in blasting or any rock fragmentation engineering subject, initiation devices, only this chart will be there. The electronic detonator is not there in the old books. Now we have to add this electronic detonators also, because olden days we classified into electric and non-electric. Under electric, the safety fuse and the non-electric. And non-electric, the shock tube initiation, both in hole and surface. Electric only millisecond and a long delay. Electronic detonator, now it is something new. So under electronic detonator, there is no need to write whether it is instantaneous or delay. It comes as a device. Whatever the delay you want, as a user, you can fix delay. If you don't want to fix a delay, it will become a zero. It is instantaneous. But there is no point using electronic detonator as a zero detonator. You have procured to produce a given delay timing. Then if you don't give any delay timing, it goes as a instantaneous detonator. It is of no use. But all electronic detonators we are using for a delay purpose only. Sorry, the delay you can fix in the logger. So coming to the blast performance, these are the basic. We have controllable and uncontrollable parameters. Under controllable, blast geometry, explosive properties, initiation system and initiation pattern. Under uncontrollable, physico-mechanical properties and geological discontinuity. So whatever is not our control, we have to take into account and control the controllable parameters. Among them, now we'll stick to only initiation system. Now coming to blast geometry, explosive properties, I think maybe other lectures may be there. I'm not going to that part. So what is basically the purpose of blasting? As you know, the breaking of the rock mass of desired size distribution is the main purpose with minimum side effects. What we need is fragmentation. Fragmentation suitable to the downstream operations. But the side effects are ground vibration, noise, and fly rock. In fact, only 18 to 20% energy of explosive is coming in the form of fragmentation. Remaining 78 to 80% is going in the form of unwanted effects like ground vibration, noise, and fly rock. These problems, these side effects, not only wasting our explosive energy, but those are causing some unwanted problems. Because the nearby villagers, they come and complain because of high noise levels. Actually, when noise levels are high, there is no correlation. If noise levels are high, there is a damage to the structure. But most of the these are called as a socio-technical complaints. As some of you may be mines manager, the nearby villagers will come and shout against the project management or against the blasting, telling that I am standing in my field, I could hear the sound, there is a big noise and my house is going to damage, no cracks have come. If noise cannot cause any damage or cracks, it is the ground vibration which will cause the damage. But as a layman, even if we are in their position, if you do not know the background of blasting, even if you are highly educated, you cannot correlate, because the noise is more, automatically you think that the intensity of vibration is more, it is causing a damage. Because as a human being, we are not so sensitive to ground vibrations, whereas noise level we can sense easily. So the far off people also giving a complaint against the blasting, mainly it is due to noise. But the damage to the structures happens to the due to the ground vibrations. When the regulating bodies comes into picture, especially the uh, DGMS, or nowadays even small sectors, the mines and geology and other SEA, State Environmental Appraisal Committee, there are so many regulating bodies. They say you get it done a ground vibration study. So what is this ground vibrations? What are the factors influencing? Again, that there is a lot of theoretical and prediction models. There are a lot on this. So whatever we have in our control, explosive parameters are these. You have to optimize that and see that you will produce lesser ground vibration, less noise, avoid fly rock, and improve fragmentation. If fragmentation is not good, also the downstream operations will influence. But the thing is that you are the owner. The next, suppose loader performance is not good, your dumper productivity is less, it is within your hands. But especially the side effects are more, the neighboring people will come into picture, into the problem, and sometimes they may halt the project itself. In fact, I started working in the initiation system way back in 2000 when I was a student of Banaras Indian University as a MTech. I think I was one of the first student to work under this. My guide, Dr. T.N. Singh, present Louis Director, IIT Patna, he told me the non-healths are being introduced in Indian market. You can start the project on non-health initiation for my MTech project. So way back in 2000 itself, I started working on that. And 2001, as a student, the first two publications were made. Later, when I joined NIT Surathkal as a faculty member, and I continued my research on initiation system, there are these are only few publications I have given. There are number of publications on my name, especially on initiation system, which are available on free on online. We have done comparative studies were done between nonal based shock tube initiation and decord initiation in terms of ground vibration, in terms of noise levels, in terms of fragmentation using different methods. So there are various studies done by us in limestone, coal, dolomite, and different formations. In fact, some other researchers also have studied in detail. There is a clear-cut difference that the noise levels are less with non-L initiation system compared to decord initiation, around 10 to 15 decibels. There is very clear conclusion on this, because there is 10 grams of PETN is there in the detonating card, whereas in shock tube only 20 milligrams of PETN is there. The PETN is major responsible for noise levels. That's what the more grammage of PETN leads to higher noise levels. That's what detonating card always produced higher noise levels. 10 to 15 decibels lower noise levels is a very good indication. And fragmentation is better always with the non-L based shock tube initiation, because of true bottom initiation. The cycle time of the shovel is 10% is better than decord initiation blast. But when you compare to ground vibrations, there is no clear cut clarity. The decord is giving higher vibration level only up to a scale distance of around 30 scale. Hope you know what is scale distance. Scale distance is distance divided by under square root of maximum charge per delay. The two parameters are merged into a single parameter called as a scale distance. So that at that time, actually this paper was published in somewhere 2005 or 2006. At that time, we were also not clear exactly why it is happening. One of the reason could be the shock tube initiation when we use the delay timings are
అయిపోయిందా పని
చేసినాం ఎవరన్నా?
అది ప్రెసిడెంట్ సార్ రూమ్ టేబుల్ సర్దేమన్నారు సార్
అయిపోయిందా?
అయిపోయింది
పో మరి.
వెళ్ళిపోనా
25 to delay is 8 milliseconds.
వెళ్ళిపోనా
Whereas in decode initiation, it is based on the chord relay. It could be 25 or 50 and all those things, right? So later what we have done, we have got one R&D project from Ministry of Core. We purchased many equipment including VOD recorder and high-speed camera. And earlier we have done only the ground vibration monitoring and noise monitoring and fragmentation using image processing analysis. At that time, 2014 or 15, and at the end of 2014, we purchased this high-speed camera from imported from Sweden. This camera will record an image at 1000 FPS, means 1000 frames per standing in viewpoint and watching that how blasting is happening, because it maximum any large scale blast also it should happen within 4 seconds. So in such a small span, it is very difficult to identify.
Sir, your screen is not
Yes?
visible, sir. Your screen is not visible.
Not
sir.
visible.
Yeah. Try to reshare the screen. No, sir.
Now, sir,
Yes, now visible. Yeah.
where we missed, I don't know. This you have seen?
Yes, sir, visible.
Yeah. Yeah, you are here.
Yeah. Okay. So here you can see these are some of the recordings we have made from field. See, based on your delay timing, as per the delay timing, the sequence initiation should take place. Now, in this you can see 4 holes got initiated here, 2 holes got initiated here, but this is getting late. Means this particular hole is not going as per the given timing. And in the subsequent second row, see the first hole is just initiating now, but second hole is already got initiated. So you can see from this, because it takes a lot of time for me to explain each and every layout, but from this you can easily identify any blasting engineer, it is not blasting as per the sequence given by you. Now in this case also, these two are going at same timing, this is going at a different timing. But in case of non-null initiated, we have not given any 2 holes we have not given same timing, but these two are going same timing. So there is something wrong in our initiation sequence. Okay, fine. Yes. You can see, you can put the layout in front of you and see that which one you are given 0, whether it is going as per the layout or not. Now just observe this video. You can see this video. Hope you are able to differentiate. Most of you must have seen real blasting in the site. Nothing will go so slow, right? Can you see similarly in the viewpoint, standing in the viewpoint? Hope you are following my lecture.
Yeah.
Yes.
sir.
Now you
Yes,
see,
sir.
you see this.
I'm
there
also
is a
following,
number.
sir. I'm also following you. Don't worry.
Sir?
I'm also following, I said.
Okay. See here one number is changing here. You can see near my cursor. Actually, this video is recorded with a high-speed camera. The previous one with a normal camera. Actually, we are recorded at a certain frame. This was recorded around with 500 frames per second. That's what it is playing automatically in a slow motion. So that's what you can see whether now you see this hole has gone first before this. So this. So now you can keep the layout and your original delay timing is there. And now as per starting from 0, you can calculate based on from the software at what timing it got blasted. So there is not exact correlation between the theoretical design what we have given and practically at what time it has blasted. From this you can also analyze further. See, there is some horizontal movement from here. And some of the holes are just blowing. Maybe the stemming is not proper. See this particular hole, or sometimes the burden may be more. It is not able to move the rock mass. You can analyze from multiple angles. Actually, what is burning on the surface, that is a detonating cord we have given only for initiation purpose. Now you see these are the two holes initiated with two different patterns. The left side is initiated with a shock tube. The right side is initiated with a detonating cord. In case of detonating cord, what is happening here? The most of the energy, explosive energy, is escaping through the column zone. The researchers have estimated that around 10 to 15% of the column charge will be burning before initiation takes place, because the detonating cord, the VOD is around 7,000 meters per second. Suppose, for example, ANFO is inside. This ANFO, ammonium nitrate and fuel oil. So when the shock wave is going into the blast hole, what happens? Whatever comes in, this fuel oil comes in contact with the decord shock wave, it will burn out. At the same time, the whatever the ammonium nitrate particles are there, those also will burn, but blasting will not take place because it is a column charge. When the shock wave goes to the bottom of the hole, there will be a primer or a base charge or a booster. Blasting will start from here. So when explosive energy is liberating, so there is a easy way already, which is the shock wave while coming down, it disturbs the stemming zone, which is called as a destabilization of stemming zone. It will destabilize a stemming zone and desensitize column charge. So explosive energy will escape easily through the column charge, and less energy is available to break the surrounding rock mass. If you put 100 kg, only 80 to 85 kg of ammonium ANFO will work, remaining 10 to 15 kg all gone waste. Whereas in shock tube initiation system, what happens? The shock wave will pass through a tube which is not directly comes in contact with the ANFO or column charge. So directly it goes to the bottom of the blast hole. It initiates the booster or a base charge that will initiate the column charge. Subsequently, the effective utilization of explosive energy takes place. That is a clear indication from this. Now it is a multi-hole blast. You can see the top are initiated with the shock tube initiation, bottom are initiated with the decord initiation. Now, still why this error is there in the performance of the blast. So what we have done, as I explained earlier, what is the error? So we calculated what is the error is taking place. See, in this row, you can see many holes are having 60 to 80% of error. At least 40 to 60% of the error is there. Suppose the hole should blast at 25 milliseconds. Either it is blasting after 25 milliseconds or it is blasting much before 25 milliseconds. So with zero error, only 1 or 2 are there. Less than 20% is 1. Surface error, it is 1. But mostly it is 20 to 40, mostly 40 to 80. There are some evidences where the error is more than 100%. Means which is supposed to blast at 50 milliseconds, it is blasting after 100 milliseconds. So in consequence, what happens? Now you take a simple example of this. The theoretical, suppose once I go to a mine or a quarry, I have given a design, a simple layout I am taking. 0, 17, 34, 51. Because row within the row it is 17 milliseconds, row to row 25 milliseconds. So 0, 17, 34, 51. 17 plus 25, 42 plus again 17, 17, 17. When you do this, at least there will be 8 milliseconds. This is the standard practice what we do in case of non-L based shock tube initiation. Now, based on this design, what we do, we fix the instruments at different locations and monitoring the ground vibration levels. There is something called USBM equation. You may be knowing how to predict the ground vibration levels. PPV, peak particle velocity equal
Your voice is broken. The break in your voice, Professor.
We can't hear the voice.
Sir, there is a small technical issue with the network. Professor Ramchandra sir informed I will be sharing the screen soon.
Now, sir.
Yeah, sir. Now it's visible. Please
Yeah,
continue.
now you are visible.
Now it is okay, sir.
Sorry.
It's okay.
This slide, you could earlier I have presented this to you. I'm not sure where we lost the connection.
Sir, last slide, this slide, sir.
This slide I have done, right?
No, this you all have explained half. You have to continue this one.
Yeah, when we do this high-speed camera recording and calculate the real time of as per the design and actually what timing it executed, there is lot of error in the delay timing. There are some errors more than 100%. Means a hole should blast at 50 milliseconds. It is blasting after 100 milliseconds. So there is no mistake from the consultant or the blasting in charge, but still the result will be different. Practically what happens? Hope this is not explained, right? Okay, anyhow, I will repeat. A simple normal layout you take 0, 17, 34 means within the row 17 milliseconds, row to row 25 milliseconds. This will be the delay timing. Simple layout I have taken. So this is the USBM equation where K and B are the constant, distance divided by under root of maximum charge per delay. The maximum charge delay will be nothing but charge per hole in this case, because each hole is supposed to blast independently based on our delay, blast design. But practically what is happening? You assume that this 34 is blasting with 10% plus error. 10% of 34 is 3.4. 3.4 plus 34 is 37.4. Right? This 42, suppose it is blasting with minus 10% error. 42 minus 4.2 is 37.8. So this 37.4 and 37.8, because both will blast at a same timing, because unless there is a minimum delay of 8 milliseconds between the two holes, we cannot take them as a separate initiation. Now we assumed that as per this it will go. Suppose the charge per hole is 50 kg. Based on substituting 50 kg, I have done the calculations and done the design. But what is happening here? This 50 and this 50, 100 kg got initiated. Suppose, as you know, circular number 7 of 1997, the DGMS guidelines for peak particle velocity, there is a structure, a house. I supposed to have the PPV below 5 mm per second. Keeping that in view, I have given the design thinking that it will give a less than 5 mm per second. But on that unfortunate day when we measured, this may give more than 5 mm per second. Why? Because this is happened. Is it my mistake? It is the initiation system mistake. Means it is not blasting exactly as per the design. I assumed 50 kg and designed, but 100 kg has happened at a single point. Then the PPV may go high. Then the mine management, they think we called this person as thinking that is a blasting expert. Yesterday it was less than 5. When expert came, it is giving more than 5. Actually, it is not the mistake of the expert. So such things will happen, right? So if you take the among the number of parameters coming to this, especially the charge weight, the charge per delay and the length of delay are considered as the most significant parameters on PPV. Now coming to the delay timing, various researchers have given this various guidelines. Even till today, there are no universally accepted delay timing. So, and in fact, the user has no control over the delay time. Suppose the day you are buying a nonal based, either you have to buy 17, 25, 42, 65, you don't have any control at the site. Or if you buy a decord with a cord relay, 25, 50 or 100, once you have purchased, you have to use the same. You don't have any control. Suppose burden is changing. Yes. But based on various theoretical studies and some of the even pilot scale study, various researchers have proposed these equations. Now you see this blast. This is the blast initiated with an electronic detonator. This is one of the coal mine in the state of Jharkhand where we have done some studies recently. I have so many videos related to different initiation systems and pattern. Now you see there is no single fly rock. 10 years back when I visited Australia, people say one professor like me was making a presentation showing a similar video. I can stand near the blast and I can do the blast. Can't we do blasting standing on this? Though the legal requirements are there, you should not be there unless there is a shelter and all. But even today, I am confident that I can stand here and blast. There is no single fly rock. Why? Earlier also we only did the same blasting team has done, the same consultant has done. There is a technological difference because in the previous initiative, I'm not blaming, I'm not sure in the audience any explosive manufacturers or initiation system manufacturers are there. There is nothing to defend here. The simple logic is the previous initiation systems, whether you take a D card or shock tube or card relay or delay detonators, there is a delay element mostly which is a chemical. So the length of delay is defined based on the length of delay element. Means the time required to blast decided by delay length. But as our timing is requirement is in terms of milliseconds, it is very difficult to exactly measure what is the exact length of delay element required. So that was the major reason why it is not possible to control into such a micro level. Though the manufacturers are saying there is a percentage of error of 10% is acceptable, but the 10% is beyond limits. The 10% error is which is not true. As I have a lot of evidences which are recorded in the field, the error is more than 100%. So now in this case, the electronic detonator, once we bring into picture, what happens, this delay timing is there is no delay element in that. There is a microchip instead of delay element. So the microchip will store the energy and you can set the delay timing in digital logger. What is the exact timing you want? So in English, school English, you might have studied what is a point of time and period of time. So the conventional initiation systems are
Sir, your audio is not audible, sir. Ramchandra, sir.
Sir, there is no audio video.